So this is Jackie with her arm around Joanne, and me with my arm around Jackie, and nobody with their arm around me, which is kind of the story of my life. But anyways, um, I'm gonna, I don't want to spend any time on Krabbe. You've heard a lot about Cyclosene, and so I think with Cyclosene now, newborn screening for Krabbe disease is no longer an issue. The precision is among the highest things we screen for, and you heard all about that. One way to think about newborn screening for LSDs, it's like I jump out of an airplane, and then a few seconds later, Dieter Matern jumps out of the airplane and hands me my parachute. That's kind of a good way to think about it over the years. I just wanted to add, so given the power of Cyclosene, for diagnosis and prognosis, why don't we use it as a first tier test? Why don't we bother with Gal-C? It's very simple, because the analysis is much too slow, 10 times slower than we need it to be. And it requires a very sensitive mass spec. So it's a no-brainer. We do Gal-C first and Cyclosene second. So we do Cyclosene on 10 or 20 samples per year per state, and it's no big deal. So I'm going to talk about MLD and CTX today. This is, in my opinion, a must-watch video on new treatment option for MLD. It's a YouTube. It's a very, very good video. It was done by the MLD Foundation. It's very well done. I highly recommend it. So my history in newborn screening with MLD started about 6 or 7 years ago. Many of you know David Wanger, not David Wanger, everybody knows David Wanger. David Whiteman, he's a pediatrician, metabolic disorder specialist, works for Takeda Pharmaceuticals, and he encouraged me to work on newborn screening for MLD. And I think we can screen for everything, but MLD was very challenging in my mind. The problem with measuring the enzyme in blood spots like we do for Pompe and MPS 1 and Krabbe and everything else is the enzyme's pretty unstable. In Florida, for example, when it's 110 degrees, I think most of the activity would be lost in a week or two. So that's kind of a deal breaker. And there's a rampant pseudodeficiency. Something like 0.5% of the population has very low enzyme activity because of pseudodeficiency, and it doesn't cause disease. So we thought immediately about measuring the sulfatide biomarker. So you're missing the enzyme that degrades a lipid called sulfatide that's present in myelin. So this is a leukodystrophy. You lose your white matter. I don't know, why are there so many leukodystrophies, right? I mean, what's wrong with white matter? I think maybe it makes sense to say that a lot of the white matter is put down after birth, and so you don't need healthy white matter to be born, and so then the trouble starts. So we have a lot of leukodystrophies, loss of white matter, Krabbe disease, ALD, CTX, MLD. So if you're missing the sulfatide, maybe the substrate, which the sulfatase, the ARSA sulfatase, the aryl sulfatase A, it's abbreviated ARSA, the sulfatide substrate would accumulate. So with the help of the MLD Foundation and Maria Escolar, we obtained dried blood spots from about 15 newborn dried blood spots from patients that went on to develop MLD. And I'm showing you data on 6 of them. All 15 would be above this dotted line. So the thing that makes me very nervous is 2 patients in particular. There's overlap with this is 2,000 random newborns. This is a sample of the reference range. So there's overlap between these 2 guys and the newborns, random newborns. So I wasn't very optimistic about this, and yet you'll see it works perfectly. So this is the amount of sulfatide in blood spot. We do this inside of 1.5 minutes by liquid chromatography mass spectrometry. That could be multiplexed with all the other diseases we're talking about. let me just tell you the results of the pilot study. Maybe I call it a research study because these are de-identified blood spots. So we don't know the identity. In Washington State, we don't have parent consent. We don't have the possibility to go around and ask all the families to consent to this study. So we use random newborn blood spots as babies are born, but they're de-identified. But you can still prove that the screening technology works. It's unambiguous. So we measure this C16 sulfatide by LC mass spec about 1.5 to 2 minutes per newborn. We think we can reduce the time to about 1 minute. We're working on that. And we obtained 15 newborn blood spots from California, a little bit New York, from the MLD Foundation, and some from Maria Escolar University of Pittsburgh. So thank you guys for that. And of course, we set the cutoff to be below the sulfatide in all 15 patients. So our false negative rate is expected to be 0. So, false negatives. In the entire planet of newborn screening, the only way you deal with this is you obtain samples from as many symptomatic patients, confirmed disease patients that you can get your hands on, and you set your cutoff to catch all of those. There's nothing else you can do. End of story. You might miss one in the future. Nobody knows. And what else could you possibly imagine doing except to set? So with our cutoff, we would catch all 15 out of 15 MLD patients. Okay, are we going to catch everyone in the future? Probably, but can we say for sure? No. And nobody can do any different. But the problem is there's overlap with the reference range. So we get about 195 newborns that have sulfatides above this conservative cutoff out of 27,000 de-identified. So we need a second tier test, and we need it to be part of newborn screening, right? That's clear. It's kind of like ALD. It's kind of like Krabbe. We need cyclosene. So we measure now the enzyme activity, okay? I mean, it might be low in warm states, but it's not going to be close to 0. And we found 2 newborns out of 195 that had very low enzyme activity. The other 193, it was more than 30% of the normal ARSA activity, and these could not possibly be MLD, okay? So we had one of these 2 had 8% of residual enzymatic activity and one that had 0%. So then Andy Warwasser at Utah Newborn Screening Lab was able to sequence the ARSA gene in the same blood spot from a single punch that we had left. And the 8% guy is probably not MLD. This baby has 1 pathogenic mutation and 2 pseudodeficiency variations. So maybe when you bunch all of this together, it could be late onset MLD, but probably not. But the second patient at 0% has well-known pathogenic mutations in trans. This baby has MLD, or will develop it shortly, but we cannot identify the baby. So the false positive rate is amazing. It's 0 to 1 per 27,000. And this works better than for most other things we screen for. We've just submitted the paper, but I can send you a preprint now. So, even without a prospective pilot study where we identify the patients, we're sure that this technology works. I think this is unequivocal, yeah. So let's move on to CTX. So Andrea DeBarber, she's an amazing analytical chemist at the Oregon Health Science University in Portland, called me up. He said, Mike, you know about newborn screening. You've launched some programs. We want to pick your brain about CTX. So CTX, is cerebrotendinous xanthomatosis. It's another leukodystrophy due to a disorder in a bile acid biosynthetic enzyme. It's pretty rare. We don't know quite how rare, maybe 1 in 100,000, but we're not sure. But it's very well treatable by giving bile supplementation therapy. So it's not a fancy treatment, and it works really well. We ended up using a biomarker initially discovered by Andrea, but we found out that marker is better suited for a second tier test. And we end up using a biomarker by Fred Vos at the Amsterdam Medical Center in Amsterdam, the Netherlands, and that was published. And Heidi Cooper and Ron Wanders and colleagues have worked on this biomarker. It's called tetralglucuronide. And the reason so Andrea called me up and I said, look, why don't we just turn on the mass spec channel for this biomarker, and we can include this for free in our MLD pilot study, and we're fully funded for that. So let's just do it for free. We ended up testing 50,000 newborns de-identified. We established the cutoff in the same way for MLD. We had 12 CTX patients. We only had a single biomarker above the cutoff, and the genotype is a clear case of CTX. So the false positive rate is amazing at 0 per 50,000. This was published in Genetics in Medicine. And I think this is prospective pilot study will start soon in the Netherlands by Fred Voss. So we're sure we can screen for CTX. Now, there's a lot of talk about phenotype, genotype correlations and the lack of them. It's a very difficult problem. It's like going to Mars. We think we're going to get there, but we don't know when. You know, don't know when means probably not in the next 10 years, but what about 20 years, 30 years? The answer is a big maybe. It could be 50 years. It could be never. If you talk to people who do cystic fibrosis in California, you know, it's complicated, right? They look at all the mutations recommended by the American College of Medical Genetics, and then they find 30% of the mutations in California come from Latin America, and they weren't in the database. And then you get variations of unknown significance, and you get partially enzyme reducing polymorphisms and that act in combination. It's a big mess. So for the foreseeable future, biochemical analysis is going to be the method for newborn screening. And you know, I think the experts largely agree, certainly the Mayo Clinic, and I think they're the best in the world. But nevertheless, BioMarin wanted to annotate all of the DNA variants that we see reported for ARSA. So we collaborate with Stephen Froelich, Wyatt Clark, and John Leibowitz at BioMarin, and we've expressed 350 approximately known variants of the ARSA gene, including all reported VUs in human cell line called HEK293 that have been genetically engineered to lack endogenous ARSA. And we measure the residual activity using a very sensitive LC mass spec assay. And we're going to submit this paper 2021. So all of the variations of unknown significance out there that don't reduce the enzyme activity very much will be reported, right? But this isn't going to solve the problem. This will help, okay? And you know, if you ask me how many prognostic accurate statements can you make if you have the genotype from newborn screening? You know, I don't know, 50%. If you look at Krabbe disease as an example in New York, something like that. It's not 100%, it's not 10%, something 50%. So let me end with Screen Plus, which is the largest prospective pilot newborn screening program in the world. It's the brainchild of Melissa Wasserstein, who's the principal investigator at Einstein College of Medicine. It's funded by NIH and biotech in an interesting collaboration. So the beauty of this and the brainchild is we can consent with in-person nurses or professional consenters at bedside in 6 to 7 large hospitals in New York. We expect 35 to 40,000 newborns per year. I mean, I simply cannot go to 20,000 birthing centers in Washington State and ask for consent. We don't have hospitals like you do in the Bronx, right? And in round one, we're going to be doing 14 new conditions. And the inclusion is that you have to have an FDA approved treatment or an advanced clinical trial status. And the list of these conditions is on the website. You can ask me. Oh, here they are. So a bunch of MPSs, GM1 gangliosidosis, Passage Bio, for example, has gene therapy trials in other companies. CLN2, Batten's disease, we have treatment. Niemann-Pick A and B, Genzyme has treatment far along. Niemann-Pick C, clinical trials. Gaucher and Fabry, you know, we screen for these in some states, but screening for Fabry has been problematic because of all the late onsets. We want to see if we can fold this into a research study to make Fabry newborn screening better. Lysosomal acid lipase, we don't screen for it, but there's a good treatment. CTX, same deal, and MLD. And we can add new conditions over time. For example, MPS IIIA we want to add next year because there's a lot of trials, and that's a very important MPS disease. Canavan disease, molybdenum cofactor deficiency, Wilson's disease, and this shows you the power of LC mass spec. We think we can screen for hundreds of diseases. I'm sorry to say, because that's going to create this. Newborn screening will not be limited by technology in the future. It'll be limited by treatment and the ability of newborn screening labs to keep up with this on a public health level. That's a challenge. And we're setting up the new assay. It's already been published in Joe Orsini's lab in New York. That's where the test will be done. And if the first tier is mostly enzyme activity is screen positive, we will reflect the blood spot to the Mayo with Dieter and me at University of Washington. We will do biomarker analysis as part of newborn screening. As part of newborn screening means using the same dried blood spot before any parent contact, because we're going to have false positives. We have good biomarkers for many of these, but not for everything. So anyways, if you survive this and you're screen positive, Melissa's team will contact the patients, and they will be then, we will get a whole blood sample for genotyping and clinical examination, and treatment options will be provided to families when warranted. A very important part of this is to capture surveys among now the general population, pretty much 50,000 babies random in New York, not just doctors and not just families, you know, with affected kids, but and Aaron Goldenberg at Case Western is going to run the survey arm of this, and we're hoping to start in September. We were supposed to start earlier, but COVID set in. And I just wanted to point out that the MLD Foundation, Dean and Terrence Sir, and their helpers are sort of administratively monitoring the newborn screening for MLD. We have the Screen Plus to start soon. There is some talk by Andy Warwasser in Utah of a prospective pilot study in the newborn screening lab in Utah, and also in Italy, and maybe other places, but these are uncertain. The Screen Plus will start soon. The MLD RUSP nomination we're starting the initial steps to prepare this. We have a bunch of expert advisor groups. I mean, Dean Sir is doing a very good job. Nomination to the RUSP will not be limited by bureaucracy. It'll be limited by technology and treatment. It'll be done as fast as possible. And you can learn more about this administrative arm on the website here. So this is my group currently at the University of Washington. I want to thank Xinying Hong and Jessica Diker. They ran the pilot study on MLD and CTX. And I want to thank Dean and Terrence Sir. Especially Taryn, got me all the newborn blood spots from MLD patients, and Maria Escolar provided about 30% of the blood spots as well. I'd like to thank Andrea DeBarber, the CTX expert, Fred Voss and Retrophin for helping with reagent availability and pilot for CTX, and a lot of funding. And I'd like to thank you for your attention.